At the end of this topic, you will be able to compute the sum of n terms of an AP.
How many seats are there in an auditorium in which the front row has A seats? Each row other than the front row has D more seats than the row in front of it. Schematically, the auditorium looks like the figure given in the picture. For convenience, let L denote the number of seats in the last or nth row. There are n rows. The front row has A seats. The last row has L seats. Let S be the total number of seats.
Now copy the diagram, turn it upside down, and place it next to the given diagram. The number of seats now amounts to the seats in two auditoriums. Thus, two copies of the auditorium produces a figure consisting of n rows, each having A plus L seats. If S is the sum of the seats in the auditorium, then 2S is equal to n into A plus L, which implies S is equal to n divided by 2 times A plus L. If the last row is the nth row, then L is equal to A plus n minus 1 into D, and the above formula becomes S is equal to n divided by 2 into A plus n minus 1 into D, which is equal to n divided by 2 into 2A plus n minus 1 into D. This gives the sum to n terms of an AP. Sometimes we are given an AP with only its first term and the nth term. How do we find its sum? Let us make matters simple. Call the nth term as the last term and denote it by L. Then the sequence can be written as shown. Now reversing the order and adding the terms, we get 2Sn is equal to A plus L n times. Thus, Sn is equal to n divided by 2 into A plus L. In other words, the sum of the first n terms is n times the average of the first and last term. Sum of the first 100 natural numbers. There is a story that when Gauss was 10 years old and in the public school, his teacher, to keep the class occupied, set the pupils to add the numbers through 100. Almost immediately, Gauss placed his slate on the annoyed teacher's desk. When all the slates were finally turned in, the amazed teacher found that Gauss alone had the correct answer, 5,050, but with no accompanying calculation. Gauss had mentally summed the arithmetic progression. He wrote the numbers and its reversed order and added them term by term. He got 101 plus 101 plus 101 and so on 100 times. That is 100 times 101. So the sum is 100 into 101. He has used each number twice. The answer would be 100 into 101 divided by 2, which is equal to 5,050. In this topic you have learnt, if the first term is A and the common difference is D, then the sum of n terms is given by Sn is equal to n divided by 2 into 2A plus n minus 1 into D. If L is the last term of a finite AP, or the nth term, then the sum of all terms of an AP is given by Sn is equal to n divided by 2 into A plus L.